Hello friends. So today we'll study about the construction of three-phase induction motor. A three-phase induction motor has two main parts. One is stator and the second is rotor. So according to the types of rotors, there are two types of motor. One is called squirrel cage induction motor and the second is called slip ring induction motor. So the rotor is separated from the stator by a small air gap which ranges from 0.4 mm to 4 mm. So that is the gap between stator and rotor is 0.4 mm to 4 mm. So it will depend upon the power of the motor. So let us start with the parts. So the first part is stator. So stator is a part to which three phase AC supply is given. Okay, so basically it consists of steel frame which encloses a hollow cylindrical core made up of thin laminations of silicon steel to reduce hysteresis and eddy current losses. A number of evenly spaced slots are provided on the inner periphery of the lamination. So as you can see in the pictures, so these are the thin laminations and these are the slots in the inner periphery. So when you combine all these laminations, you will get a stator core, which is made up of silicon steel laminations. So the insulated connected to form a balanced three-phase winding. So basically, winding goes into these slots, which forms three-phase winding. So this three-phase winding may be connected in star, or delta. So it will depend upon the requirement. So the three-phase stator winding is wound for a definite number of poles as per requirement of speed. So the winding is connected in such that it will form number of poles. So number of poles may be 2, 4, 6, 8 as per the requirement. And the speed of the motor will depend upon the number of poles. So when three-phase supply is given to the stator winding, a rotating magnetic field. So when we have given the supply to the stator winding, there is RMF, that is rotating magnetic field of constant magnitude is produced. So this rotating magnetic field induces currents in the rotor by electromagnetic induction. So basically, the principle is for the operation of motor is Faraday's law of electromagnetic induction. Means three-phase supply is given to the stator winding, then three-phase balance currents will flow to the stator winding, and it will produce a constant rotating magnetic field, and it will induce an EMF in the rotor circuit. And this three-phase winding is mechanically and electrically spaced at 120 degree. Okay, the winding is mounted on the laminated iron core to provide low reluctance path for the generated flux by AC current. So basically, in stator circuit, or when we say stator of induction motor, again there are two components. One is called winding, and the second is core. Okay, so winding is made up of material which has low resistance, and the core is made up of magnetic material which has low reluctance. So this is about the stator circuit. So the conclusion is stator has two main components. One is stator winding, second is stator core. The winding is made up of material with low resistance, and the core is made up of material having low reluctance. So three-phase supply is given to the stator winding, and it will produce a rotating magnetic field, and that rotating magnetic field links to the rotor circuit. This is the actual picture of stator. So this part is called as stator. This is your stator, and these are the stator slots in which three-phase winding is placed. It may be connected in star or delta. Okay. So here we have a terminal box, one terminal box to which three-phase AC supply is given, so that the balanced AC current will flow through the winding. Now this is called stator frame to protect the stator, and this stator core is made up of thin laminations of silicon steels like this. These are the thin laminations which are made up of silicon steel, that is magnetic material, and this is called three phase winding. So the second part is rotor. Rotor is also built up of thin laminations of the same material as stator, so that is magnetic material, silicon steel laminations. The laminated cylindrical core is mounted directly on the shaft or a spider carried by the shaft. These laminations are slotted on their outer periphery to receive the rotor conductors. So the one difference between stator and rotor is stator has inner slots at inner periphery, and the rotor has slots at outer periphery, and these slots will carry rotor conductors. Again, there are two types of induction motor rotors. One is squirrel cage rotor or simply cage rotor, and the second is phase wound rotor or slip ring rotor. So motors using this type of rotor are also called slip ring motors. Now let us start with the first, the squirrel cage rotor. So this is the structure of squirrel cage. So this is the animated pictures, and this is what your actual squirrel cage rotor. So it this squirrel cage rotor consists of a laminated cylindrical core having parallel slots on its outer periphery. So these are the parallel slots. One copper or aluminum bar is placed in each slot. All these bars are joined at each end by a metal ring. So this is what your metal ring. These rings are called end rings. So this forms what is the benefit of this end ring is this forms a permanently short circuited winding which is indestructible. That is, you cannot modify it. So the entire construction, or that is bars and end rings, gives you a squirrel cage, and hence the name. So the name is squirrel cage rotor because this structure forms a cage like structure. Okay, so this is like a cage structure. The rotor is not connected electrically to the supply but has current induced in it by transformer action from the stator. So there is no actual supply given to the rotor as in DC motor. The current flows through these conductors by using induced EMF. The supply is given to the stator winding, and so that by rotating magnetic field, there is induced EMF in the rotor bar. So those induction motors which employ squirrel cage rotor are called squirrel cage induction motor. Most of three-phase induction motors use squirrel cage rotor as it has remarkably simple and robust construction. But it has some disadvantages, that is low starting torque. These have low starting torque. And the one point is you cannot connect external resistance to these rotor conductors, as you can have this simplicity in slip ring induction motor. So this is what your slip ring rotor or phase wound rotor. Okay, so what is the difference between squirrel cage? Squirrel cage, that you cannot add external resistance, but in slip ring or phase wound rotor, the rotor winding is like stator winding, that is, it is connected in star. It is connected in star. So the structure is same, but the placement of rotor winding is different. Okay, so basically this winding is externally, can be externally connected to the resistance. So for that purpose we use slip rings on the shaft. So by using slip ring and brush arrangement, you can connect external resistance to the slip ring induction motor, but it is not possible in the squirrel cage induction motor. So this is what your phase wound rotor, that is slip ring induction motor rotor. So these are the slip rings to which brushes are connected, and externally you can connect resistance, and the resistance may be in star connection. Likewise. Now, what is the difference between squirrel cage induction motor and slip ring induction motor? So the this is the difference between squirrel cage induction motor and slip ring induction motor. So in this, rotor is in the form of bars. In slip ring induction motor, the rotor is in the form of three-phase winding. So this is the main point. In squirrel cage induction motor, no slip rings and brushes. But in slip ring induction motor, there are slip rings and brushes. We cannot connect external resistance in squirrel cage induction motor, but in slip ring induction motor, you can connect external resistance so that you can vary rotor current. For squirrel cage, small or moderate starting torque. So this is the, we can say, disadvantage or limitation of squirrel cage induction motor, that it has low starting torque. But in slipping induction motor, by varying resistance, you can get high starting torque. For squirrel cage induction motors, starting torque is fixed, that you cannot change. But by varying rotor resistance, you can vary starting torque. The construction is simple for squirrel cage motor, but due to slip rings and brushes and the three-phase windings connections, the construction is complicated for slip ring induction motor. Efficiency of squirrel cage induction motor is high. Efficiency of slip ring induction motor is low because due to brush loss and the external resistance drop. The cost is less for squirrel cage. The cost is more. Again, the squirrel cage induction motor has less maintenance, but slip ring induction motor requires frequent maintenance due to slip rings and brushes. The next is the starting power factor is poor, but when the induction motor is squirrel cage induction motor is running, the power factor is better. For slip ring, starting power factor is adjustable. By varying resistance, you can adjust the starting power factor, but low power factor on full load. Again, the size is compact, and the size of sleeping induction motor is relatively bigger when you compare for the same size or same capacity. For squirrel cage, speed control by stator control method only, but in slip ring you can control by both stator as well as rotor. So what are the applications of squirrel cage induction motor? For driving constant load, for example lathe machines, workshop machines, water pumps, etc. And slip ring induction motors can be used at heavy loads where high starting torque is required, for example, lift, crane, elevators, conveyor belts.